let's try another set of examples. So we're using the same picture, but it looks like we're talking about the x value of 8 this time. So I'll do the same thing. I'll copy this. I'll copy this. And I'll put it next to the picture so that I don't have to go up and down when we talk about this. Okay, so the number we are interested in for this set of problems are 8. Not -8, because if it's -8, we gotta have a negative sign in front. We don't have a negative sign in front. X is approaching 8 from the left. So when you look at this one, we're looking at the left-hand limit. Left-hand limit. Now the second one over here, I'll do that one next later. But this one is approaching 8 from the right with this plus sign. That means it's coming from the right. So this will be right-hand limit. Now listen, if this left-hand limit equals the right-hand limit, then we get to say that the general limit down here, you see how this one doesn't have any, the one that I'm about to highlight in green, you see this doesn't have any plus or minus sign for the 8 here, right? So this is talking about the general limit. This, the general limit. Answer for part C only exists if A and B are equal. If they are different, then we're going to say it does not exist. Okay, so let's start this process. So let's go find 8 on the x-axis. Where is 8? So there's 5 right there. So 6, 7, 8. Here is 8. So let's see what's happening when the x value is equal to 8. So I'm going to go straight up. Oh, I see. Oh, look at that, guys. There is an open circle. At what value? Let's take a look. What is the y value? How high up is this? It's 1 below 5. So the function value or the y value must be 4. Right? So we have an open circle at 8, 4. This one right here. But limit is, what they're getting really close to. So take a look. I'm trying to get to this open circle from the left. So if I try to go to this open circle from the left, I am approaching the y value of 4, right? So the limit does exist. The left-hand limit is 4, because from the left, I'm getting really close to the y value of 4. And it's the same for the right-hand limit. Notice that if I start from the right side of 8, so somewhere from 10 and go to the left, notice it's approaching that same open circle of 4. So both the left-hand limit and the right-hand limits are 4. They are approaching the same open circle right here. So guess what? Does the general limit exist? Are these two the same? Yes, they are the same. So we're going to say the general limit of f of x as x approaches 8 is equal to 4. So listen, limit does not have to have a closed circle. The function does not have to be defined for it to have a limit value, okay? But the last question, guys, over here, I'm asking for f of 8. So down here, I'm asking for the function value at 8. I am looking for a closed circle at 8. I'm looking for a closed circle at x equals 8. Do we have a closed circle at x equals 8? We do not. We have an open circle. So guess what? The function has a hole at x equals 8. See, we do not have an open closed circle here. So for f of 8, we have to say this is f of 8 is, it does not exist, it's undefined. It's undefined. Okay? This function is not defined at x equals 8. Now, for the last question, you have to determine the continuity. For a function to be continuous at a point, we have to compare the limit and the function value. They have to be the same. On the previous page, take a look. On the previous page, the limit was 7 and the function value was 7. Notice they were the same. when the limit equals the function value, we get to say that this function is continuous at x equals 5, okay? Do we get to say that over here? Well, the limit is 4, but the function is not even defined. So guess what? When they ask you down here, continuous, we're going to tell them no. No. We'll say f is not even defined at x equals 8. So it cannot be continuous. In pre-calculus class, we learned that we should be able to sketch a graph without lifting our pencil, okay, to be continuous. Look at what happens. I can sketch this graph without lifting my pencil here, but when I get to that x of 8, I have to lift it and go to the other side because we have a broken part right here. We have an open circle right here. So in section 1.2 though, we have to use this continuity definition. So what I want you to do is find me the limit, find me the function value, and compare them. They're different, okay? Well, they both have to exist first, right? So that's how you can tell, well, this point was a little different because even though the limit existed, it wasn't continuous because we had an open circle, okay? So this was a second example. Let's look at another one in another video.